AI agents are one of the hottest topics in software development right now. Everywhere you look, people are talking about AI agents, autonomous agents, multi-agent systems, agentic AI. And as a .NET developer, you might be wondering, what actually is an AI agent? Is it just a chatbot with a different name? Is it an LLM? Is it basically RAG? And how does an AI agent actually fit into a .NET application? In this video, we're going to break it all down from a .NET developer's perspective. So, let's start with the big question. What is an AI agent? Let's keep this simple. An AI agent is a system that uses AI to work towards a goal. But instead of simply generating a response, an agent can potentially understand a request, decide what needs to be done, access information, use tools, take actions, look at the results, and decide what to do next. For example, imagine you ask an AI, find all failed payments from today and send me a summary. A simple chatbot might just tell you, I can't access your payment system. But an AI agent could potentially do something like this. First, understand that you want information about failed payments. Then use a tool to retrieve the payments. Then analyze the results. Then generate a summary. And finally, use another tool to send that summary. So the flow might look like this. User request. AI agent. Retrieve failed payments. Analyze results. Generate summary. Send email. Return the result. The important difference is this. An AI agent doesn't just generate text. It can use capabilities from other systems to help achieve a goal. And as .NET developers, this should already sound familiar. Because we already have APIs, databases, services, business logic, Azure services, and other applications. An AI agent can potentially interact with these existing systems. So, is an AI agent just a chatbot? Not exactly. A chatbot might work like this. User asks a question. The LLM processes the question. The chatbot generates a response. For example, what is dependency injection? The chatbot understands the question and gives you an answer. That's it. Now let's look at an agent. You might say, check my recent orders and tell me if any of them have been delayed. Now the AI needs information that it doesn't already have. So the agent might understand the request, identify that it needs order information, call an order API, retrieve the results, check the delivery status, generate an answer. The agent is doing more than just answering based on what it already knows. It is interacting with other systems. So a simple way to think about it is, a chatbot mainly talks. An AI agent can talk, think through a task, and take actions. Of course, there can be some overlap. A chatbot can also use tools. And an AI agent can have a chat interface. So these aren't always completely separate things. But generally, agents are designed around achieving a goal, not just generating a response. Now let's talk about another important distinction. The difference between an LLM and an AI agent. An LLM, or large language model, is the AI model. For example, you can think of the LLM as the part that can understand language, generate text, interpret instructions, analyze information, and help decide what to do. But by itself, an LLM doesn't automatically have access to your systems. Imagine you ask an LLM, how many orders did we receive today? The LLM doesn't automatically know, unless that information is already included in the prompt or available through some connected system. Now let's add an agent around the LLM. The architecture might look something like this. User, AI agent, LLM, available tools, The LLM can help the agent understand. The user wants today's order count. The agent then has access to a tool. Get today's orders. The tool retrieves the information. The result goes back to the agent. And then the LLM can generate the final response. So I like to think of it like this. The LLM is the brain. The agent is the system that gives that brain instructions, tools, context, memory, and the ability to take actions. Of course, that's a simplified explanation. But it's a useful mental model. Tools are one of the most important concepts when it comes to AI agents. A tool is basically something an agent can use to interact with the outside world. For example, search a database. Call an API. Retrieve customer information. Search documents. Send an email. Create a support ticket. Check the weather. Schedule a meeting. As .NET developers, we already build these capabilities all the time. Imagine your application already has services like customer service, order service, payment service, notification service. An AI agent could potentially use these capabilities as tools. For example, imagine a user says, "Find my last 3 orders." The agent might determine, "I need order information." It then uses the appropriate tool. The tool talks to your existing order system. The result comes back. And the agent can answer the user. Something like, "Here are your last 3 orders." This is one reason AI agents are particularly interesting for enterprise applications. Most companies already have lots of systems, lots of APIs, lots of business logic, and lots of data. AI agents don't necessarily replace those systems. Instead, they can use them. Another important concept is memory. Normally, an LLM doesn't automatically remember everything forever. It only knows what you provide to it as context. So agents often use different approaches to memory. The first is short-term memory. This could include information from the current conversation. For example, you tell the agent, "I'm looking at customer 123. Then later you say, "Show me their recent orders." The agent can use the previous conversation to understand who there refers to. That's short-term context. Then we have longer-term memory. This is where information can be stored outside the model. For example, a database, a vector database, a search system, or another storage mechanism. The agent can retrieve information when it needs it. For example, what problems has this customer reported previously? The agent could search previous support tickets, retrieve the relevant information, and use that context to answer. The important thing is that memory doesn't necessarily mean the AI model magically remembers everything. Usually, the information is stored somewhere else and retrieved when needed. Now we get to one of the most important ideas. The agent loop. A simple AI interaction might look like this. Input. LLM. Output. But an agent can go through multiple steps. For example, understand the goal. Decide what to do. Use a tool. Observe the result. Decide what to do next. Use another tool. Return the final result. Let's use an example. Imagine you ask, "Find failed payments from today and send me a summary." The agent starts with the goal. First, it understands the request. Then it decides, "I need to find today's failed payments." So it calls a tool. The tool returns the payments. The agent then observes the results. Maybe there are 10 failed payments. Now it decides what to do next. It creates a summary. Then it sees that the user also asked for that summary to be sent. So it calls another tool. The email is sent. Then the agent can respond, "I found 10 failed payments and sent you the summary." So rather than input, output, we have goal. Think about the next action. Take an action. Observe the result. Decide what happens next. Repeat if necessary. Produce a final answer. This is one of the key ideas behind agentic systems. Now let's talk about something that can be confusing. RAG versus AI agents. RAG stands for Retrieval Augmented Generation. The basic idea is: the user asks a question. Your application retrieves relevant information. That information is given to the LLM. The LLM generates an answer. For example, you might have thousands of company documents. The user asks, "What is our annual leave policy?" Your application searches the documents, finds the relevant policy, passes that information to the LLM, and the LLM generates an answer. That is Retrieval Augmented Generation. Now, an AI agent can potentially use Retrieval Augmented Generation. Imagine an agent has several available tools. Search company documents. Query the customer database. Check order status. Send an email. The agent can decide which tool it needs. If the user asks a question about company policies, the agent might decide, "I need to search the company documents." So it uses the Retrieval Augmented Generation system. If the user asks about an order, it might instead query the order system. So Retrieval Augmented Generation and agents aren't really competitors. You can think of Retrieval Augmented Generation as a way to retrieve information. And an AI agent can use Retrieval Augmented Generation as one of its capabilities. A simple visual would be: AI agent. What information or action do I need? Search documents, Retrieval Augmented Generation. Query database. Call API. Send email. This is why agent architectures can become very powerful. The agent can choose between different sources of information and different actions. Now let's look at single agent and multi-agent systems. A single agent is exactly what it sounds like. You have one AI agent. That agent has access to instructions, tools, and information. For many applications, this is enough. For example, a customer support agent. It can search customer information, search support documents, create tickets, and respond to customers. That's a single agent. But sometimes you might want multiple specialized agents. For example, imagine your application processes incoming emails. You could have a spam detection agent, a duplicate detection agent, a categorization agent, and maybe a response agent. The flow could look like this: incoming email, orchestrator, spam agent, duplicate agent, categorization agent. Combine results. Take the next action. Each agent has a specific responsibility. This is similar to how we already structure software. You might have a payment service, an order service, a notification service. Each one has a responsibility. A multi-agent system applies a similar idea to AI agents. But here's something important. You don't automatically need multiple agents just because multi-agent systems sound cool. In fact, I would recommend starting simple. Start with one agent. Give it a clear goal. Give it a small number of tools. And only introduce multiple agents when there is a real reason to separate responsibilities. Because more agents can also mean more complexity, more AI calls, more latency, more cost, and more things to monitor. So the best architecture isn't necessarily the one with the most agents. It's the one that solves your problem effectively. Now let's bring this back to .NET. One thing I find interesting about AI agents is that they fit very naturally into the applications we're already building. Imagine this architecture. Your user interface. ASP.NET Core Application. AI Agent. Your existing services and tools. And those tools could connect to SQL Server, Azure Services, external APIs, company systems, Azure AI Search, message queues, or whatever systems your application already uses. The important thing is, you don't need to throw away your existing architecture. You still have your ASP.NET Core APIs, dependency injection, business services, authentication, authorization, databases, logging, monitoring. The AI agent becomes another component of your system. For example, your application might already have a customer service responsible for customer-related business logic. You don't want an LLM directly connecting to your database and doing whatever it wants. Instead, your application can expose controlled capabilities. The agent can use those capabilities through tools. This allows you to keep control over your system. Your existing services still handle the actual business logic. The AI agent helps determine when and how those capabilities should be used. That's a really important idea. The AI agent doesn't replace good software architecture. You still need all the things we care about as developers. Security, authentication, authorization, validation, error handling, logging, observability, and testing. In fact, once AI starts making decisions and taking actions, these things become even more important. There are frameworks in the .NET ecosystem that help us build these agentic applications without having to implement everything ourselves. In the next video, we'll take one of these approaches and actually build an agent. Stay tuned, and in upcoming video we will do a hand-on demo of how to use these frameworks. If you enjoyed this video and learned something new, don't forget to like, subscribe, and click the bell icon to stay up to date with all my latest .NET and AI content.